Welcome, everyone. This is the webinar for Strata buildings, but it can apply to actually any buildings. It is converting makeup air units to heat pumps for cooling. And Jameson Vong from Stantec Consulting, who has very good recent experience with this, is one of our co-speakers. And Brenda Scott from BC Hydro is also joining us, and she will talk about grants and programs that are available. And I'm Tony Giaventu, and I will be walking you through the session, and we will have dialogue throughout the session. If you have questions, please use the Q&A or the chat. Doesn't make any difference. It'll come to us as a question, and we'll respond back as we go through the video. Just a note of thanks to Advantage Property Management, all of our business partners make these webinars possible and help support all of the education programs that we do for our members. A little privacy note, if you do put any information into a chat question, just don't identify your Strata Corporation, your name, etc. Individual names or how you logged in, that's fine, that won't be disclosed. But we just want to make sure that we protect everybody's privacy as we go forward. And of course, just a little reminder, we have probably about 8,000 buildings throughout the province that are affected by makeup air units. So whatever you hear is going to be fairly general because the details and specifications of each property are going to be quite unique. So typical makeup air system, these are across most of our apartment buildings, except with a few exceptions of much older buildings that have been conversions. And they basically draw air, hopefully from the rooftop. Not all of them do. Some of them actually draw in at ground level, which is a separate complication, but they draw in air at the rooftop. They have a blower. They frequently have a heating unit, a gas heating unit for the winter season. They have filters, although again, depending on the age, not all have filters. And then they blow through ducting, pressurization into hallways and to elevator shafts to help pressurize a building system. The reason for that, of course, is quite interesting because A, it ensures we get circulation of fresh air into our building systems. It provides pressurization in the corridors of our buildings, which are our common areas, prevents chimneying effects, which occur in vertical shafts in our buildings. It does provide us with some climate control, and of course, depending on the system, can provide air filtration. Our fresh air into our building systems guarantees that there's a minimal of exchange of fresh air, and this is for health and well-being. This also results in fresh air coming under your doors and into your units to increase air circulation throughout the buildings. People often put in things like door stops or some sort of barriers to prevent this, and it does have an impact on the cycle of your units. Fresh air helps to reduce odors and humidity and condensation buildup. It reduces the risk of mold and corrosion of components. Don't forget, elevators and mechanical equipment are all exposed in common areas, and the cycling of fresh air will help to reduce the buildup for these. And most important in our buildings, and 2 years ago, we saw a significant number of these across the Lower Mainland. If our systems are operational and the heating is operational, it prevents freezing temperatures that affect building systems, such as emergency sprinkler systems, which are in common areas quite often. Pressurization prevents chimneying up stairwells. So if you probably notice this, if your makeup air system is down and not operating, you get into your elevator at your parking garage level, all of that parking garage exhaust will go up your chimney shafts, your elevator shafts through the chimneys of the building, and it will create a chimneying effect. And that it's not healthy. It reduces the life cycle of building components. And it will also take things like salt and dust and bring them up through your building systems. Filtration, some buildings, as they've done their conversions and upgrades to new systems, have put in significantly higher levels of filtration. And this can really help to reduce the impact of exterior smoke and particulate contamination. So that's a really important part of the cycle of makeup air units as we upgrade them and we convert them. Climate control is also incredibly popular and absolutely necessary. heating and cooling. We know from the heat domes and from periods, even though they may be quite short, that what we're doing with our makeup air systems, if we don't have cooling, we're basically extracting supercharged heated air off of the rooftops, and that's getting pumped into our buildings, which is compounding the heating effect. So it's a health and a safety issue, really, during extreme heat and cold periods, especially in summer during heat domes with Metro Vancouver. But you get out into the province where we have much colder winters, it's important that the air is regulated to ensure a stable climate. And then, of course, building components require stable temperatures. So you will actually have certain types of components associated with elevators and electrical equipment that has limitations on temperatures. Otherwise, the warranty may be void on those products. If you're in newer buildings or older buildings that have done upgrades, it certainly has an impact for you. Conventional makeup air systems are only heating and they operate during the winter period. And unfortunately, strata corporations try to save money by setting them lower or turning the heating off. It does actually compound to create greater problems for your buildings. Many of them have minimal air filtration, and just looking around and looking at buildings, even the ones with air filtration, often the filters are not changed frequently enough, maybe once a year. Given the time of year and the activity, it's almost a monthly effect. They are fired by natural gas for the most part, and that's where the heat source comes from. And then, of course, we now have a lot of aging components that they have a low power draw because it's only a circulation fan. But when we do conversions, we're going to have a higher demand for power. So here's some of the liabilities that we have right now. We have no cooling. We have the problem of supercharged heated air coming from the rooftops. We have ground level intakes where if a vehicle is parked, you'll probably see a sign somewhere that says, don't let your vehicle idle in this area or something like that. That means it's an air intake for a circulation system or a makeup air system. We have aging systems that are failing, that are inoperational. And I'm actually quite surprised at the number of systems that are not operational, that strata corporations have just simply not upgraded, maintained, or serviced them. And then, of course, we have filtration. It's insufficient, especially when we have extreme smoke and fire periods in the province. It's now becoming quite an issue. I think everybody shares the same objectives: controlled, consistent climate, cooling for the summer, which will affect units, increase filtration for air quality, reduce the GHG emissions. And in areas where we have a high demand for high capacity, hybrid systems are still available to ensure we have effective heating during extreme cold periods. So all of them, all of these objectives, wherever you are in the province, can easily be met. Compatibility, this is where we get into some real problems, and I'm going to get Jameson to get on board here now, because as an engineer, we're discovering that the size, the weight, the power source, the fire safety systems, the mechanical connections, vibrations, sound, all of these items are really across the board have to be dealt with before you're actually looking at your new system. Jameson, when we've been doing these, how much heavier are the hybrid systems?
They typically tend to be heavier, and also especially when we do the design, we typically have to take a look at the existing system to see if they are originally sized correctly in the first place. And sometimes, often we find that they may not be sized correctly, and then we actually have to put in bigger units to give us more capacity. So they tend to be a bit heavier quite often.
And then we're also dealing with two types of buildings, right? We're dealing with the combustible, the wood frame buildings, and the non-combustible, which are essentially the concrete buildings. And concrete buildings may be able to support the additional capacity, but I'm going to guess that the wood frame buildings probably need structural upgrades of some sort.
Yeah, usually that's usually the case. Although concrete buildings usually they are okay because they are sitting on a concrete slab. But occasionally the system might actually still be too heavy. But the wood frame buildings, quite often you need to have some kind of upgrade and or maybe you have to pick a location where you have adequate support to take on the weight of the new system.
Sounds like this might be an ideal time to coordinate this with the new roof at the same time.
Yes, for sure. Yeah, because once you do the upgrade, structural upgrade, you probably will have to rip out the roof, and then or at least make some alteration to the roof waterproof membrane on the roof, and it will be the ideal time to do it together.
Right. So it's a good thing to look at when we're planning re-roofing at the same time for buildings, because that's a 20-25 year cycle for most buildings.
Yeah, for sure. Yeah, you definitely don't want to be ripping up to be replacing the roof, and then a year later you realize you have to do this and you have to do it again.
Yeah. So this has been a real challenge, of course, is coordinating the fire safety systems. Because the system will shut down if there is a fire alert. It's designed to shut down. But coordinating this and the mechanical connections, this has been a little wee bit of a daunting task for some of these projects.
Yeah, it is. And sometimes what we find is the fire safety system and some of the dampers they may or may not be done correctly in the first place. And then so often when you go in, then you may have to find that some of the modification needs to be done at the same time.
I think my experiences over the years has shown that we don't have enough routine cleaning of the ducting of these systems. And so again, here's another opportunity. If you're going to be doing the upgrade and the conversion and you have the systems that are basically inoperable, here's a great opportunity to make sure that the actuators and the systems are basically all operational and cleaned out.
Yeah, that's for sure. Yeah, once when we're already spending all that time, effort, and money and disturbing the occupants, then you may as well do all those at the same time.
And then the other thing, of course, is that the electrical demand for a heat pump is substantially higher than just for a makeup air unit with a blower. So that, I don't know, have you found there's sufficient electrical in location, or is it required significant upgrades?
Depending on the system that you're putting in, but quite often, as you said, we do have to upgrade the electrical system. When we do this type of project, often at the beginning, when we usually do a feasibility study to look at the building, look at the structural capacity of the base building to see if they can handle the weight, and we look at the electrical, whether the panel has sufficient power to take on the new system. So quite often we have to run new wires because the new system requires so much more power.
So it's a flag for an electric planning report then too, to
Yeah.
understand whether you have capacity in the buildings for everything else as well as this.
Yeah, that's right.
Yeah. Mechanical connections, again, like we have different systems, different sizes, the blowers, the connections to the systems. How have you found that the integration has worked?
The with the mechanical connection, as I said earlier, we ran into some projects when the connection wasn't done to the greatest, or at least it doesn't meet the current standard that we have nowadays. So they quite often we will require some kind of upgrades.
How is heat pumps in, especially in hot, warm periods with high humidity, produce quite a lot of condensate.
Mhm.
So again, here's a roofing issue to ensure that wherever the heat pump is, do we have sufficient drainage nearby?
Yeah, that's right. Yeah, otherwise we'll end up with a bunch of water ponding somewhere. Then we do want to look at where the condensate is going, and then and provide the appropriate drainage at the correct location. Because previously they may not be any consideration for that kind of things with the old systems.
Right. So the two biggest questions we always get when we're talking to strata corporations is this going to increase the noise on the rooftop? I live in a penthouse unit, I'm underneath. And the other question is what happens with vibrations? So, like I think I would like to say, I think the industry is addressing this, but I can't commit you know, my reputation on this that 5 years down the road, you're not going to have an issue.
Yeah, with the newer system, the noise is definitely a lot quieter. So you're not getting as much issues. But after all, you're dealing with a mechanical unit. It moves. The motor runs. So there's definitely some noise, but it's not any noisier than the old system that you have. If anything, it probably will be better. And again, with the vibration, is a moving part, right? So there will be vibration, but the system usually come with a noise with a vibration absorbing absorber. So if installed properly, then that shouldn't be a problem.
Yeah, yeah. Do they are any kind of external type shocks or systems installed to absorb noise?
Yeah, they typically will have. I mean, if you specify the correct system, they would come with a bumper to absorb the vibration. Yeah, but
Right.
obviously it needs to be specified correctly and to make sure that it makes it into the specification.
Well, success of everything usually falls on the correct procedures following in the first place. You, you talked about the process. There are a lot of components to evaluate. Maybe if you just walk through it a little wee bit from a consultant's perspective. Strata's called you. They're a mid-rise building of 18 floors. They want to convert to a heat pump and look at the modifications. So maybe just do a little walkthrough for us.
Yeah, for sure. Yeah, if we were to take on an assignment to do this, and then I think our design process can be broken down into a couple stages, and each stage will have some decision making along the way for the owners. And after all, as an engineer, our role is to provide options to the owner so that we can provide the best system that meets your needs. And then I think the stage one, I'll call it the initial assessment stage. This is the stage where we are trying to decide, are we going to do this or not? So we'll usually, at this stage, we'll usually look at the energy consumption of the system of the building that you have, how much energy are you using, and so we set a baseline, and then we have to do an assessment of the current condition of the equipment. For example, whether we find out how's the equipment operating right now, and do we need replacement soon? And then we do a cost benefit analysis and figure out what the payback period, because when you replace a system, obviously it's going to cost some money, but presumably the new system is going to provide you some benefits, and some of that benefit could be cost saving. So what's the payback period? Are there any funding available? I think later on, BC Hydro is going to talk a little bit about the funding availability side. And once we go through this assessment exercise, the owner can make an educated decision to decide, okay, are we going to go for this or not? Are we gonna take the plunge and proceed with this? And then if the decision is yes, then we will go into the second stage. I call it the feasibility study. So this study, what that means is, in general terms, is what we're trying to find out is so what does it really take for us to do this? And at this stage, we're going to look at a preliminary level, what kind of equipment are we going to use? Are we going to replace something like with like, or do we need to upsize the building, the equipment to meet the building's need? And then, like what we touched on a little bit earlier, if we're going to put in this kind of system, and what's the weight, and what kind of structural capacity do we need to take on this new equipment? And do we have enough electrical capacity? And what are the ducting, and what are the dampers, and all those feasibility issues to determine. So if we're going to do this, uh, how much work do we need to do, and how much money is it going to cost? And sometimes the money side might even involve either a cost consultant or maybe a contractor to give us some pricing guidelines to see where we're at, and then so the owner can again make an educated decision to say, okay, are we going to commit to do this or not? And once the decision is made, then you get into the nitty-gritty. I call it stage three, the design phase. At this stage, we are full on doing the design. That involves the mechanical engineer, the structural engineer, electrical, and then and probably tie in with the architectural team, because you're probably doing some kind of roofing membrane replacement to support the unit. And then and after the design is done, then there will be probably attend the stage and then get into the construction. But I can spend hours talking about construction and all the submittal review and field review, but that's probably a different topic this time. But in a nutshell, at a high level, this is what we go through.
Yeah, it's not a simple process of calling a contractor to just come in and do the install. This is quite different than a heat pump that's being installed on a unit because it involves the integration of the building's mechanical systems. So it's and as we found in some of the projects, there are all kinds of surprises no one had anticipated. Once you open things up and once you remove the old system, you might be discovering defects, code issues that have to be addressed at the same time.
Mhm. Yeah. Yeah, we often find those kind of surprises, and hopefully during the assessment and feasibility study stage, and we'll catch most of them, and then but every once in a while you'll find a surprise that you're not expecting.
So, we've let's say we're at the process, we've got the cost evaluation, the consulting and whatnot. Everybody always asks the question, how much does this cost? Absolutely no idea until we get to a real design feasibility stage to have a sense of the component, the modifications that are necessary, electrical upgrades, everything else that's necessary for the fire safety systems. But it's looking like on an average, mid-level building that's 12 to 18 floors, it's looking like the cost is somewhere between $150,000 and $200,000, including a component. So it is a costly venture, but the benefits are quite substantial. And makeup air systems don't last forever. At some point, they have to be replaced anyhow. So scheduling this for a cycle is an appropriate thing to do. So we have electric planning reports that link into this with Resex Power, but we also have depreciation reports now too, because they're going to set out the life cycle for something like a makeup air system as we go forward. All right. From the strata perspective, it's time that it's timely with respects to budgeting. I think that strata corporations, strata councils, when they're working with their consultants on the cost estimates, need to look closely, including contingencies for unknowns as to what the cost is going to be. And the question that comes up is not about cost, but can we, if we have a depreciation report, replace like for like? And is there even an option? There may not be, depending on local government regulations, you may have a requirement to be looking at the feasibility of a heat pump for your makeup air system now. So again, go in detail, go through the consulting process. But make sure that the other side of this, which we see frequently falling down now, is that's fine, get the conversion and the installation done, but you have to ensure that the strata budgets for the maintenance and the filtration management, because it's the only way you get the successful performance out of the components. Big part of the cycle. So I think, Jameson, you could safely say it's been quite a lot of work for each one of them.
Yeah, each one of them is a lot of work, and each building is a little bit unique. There isn't really a one-size-fits-all solution.
Yeah. Okay, so let's just jump in now for funding programs for Brenda, and then we'll just pop into questions for everybody because I see a bunch of questions popping up. So Brenda, all over to you. Just tell me when you want me to flip a slide.
Yeah, thanks, Tony, and thanks, James. Yeah, that was very insightful. And yeah, I guess this next few minutes, like about 10 minutes, I'm going to spend just talking a little bit about BC Hydro funding programs that tie into this conversation about upgrading makeup air units, but also I'm just going to give a more general overview of what our funding, what funding we have available for, and what types of systems we provide funding for. So my name is Brenda Scott. I'm a program manager at BC Hydro. I oversee energy efficiency programs specifically for the multi-unit residential building sector. So that means condo buildings, strata corporations, but also the rental market rental sector. So next slide. So we largely have two pathways or two offerings in market right now. As of last year, summer of last year, we introduced the second one. So and these two pathways depend on how and what types of upgrades we're looking at. So the MERB retrofit program, this is an offer that was launched towards the end of 2024. It is a program that was launched in partnership with the province of BC through their Clean BC offerings. And then the condo and apartment rebate program, this is a program that is more targeting residential customers, so individual condo owners. We launched this offer in July of 2025. And this is essentially rebate funding for installation of heat pumps, both heat pumps for heating, meaning mini split systems, and also heat pumps for domestic hot water. So I'm going to expand a little bit on what the whole building program is, because this is relevant for this conversation we're having today. The intent of this program is to essentially enable and provide funding for customers to make energy efficient upgrades in their buildings. And what types of upgrades and systems? We're talking about main central systems within a building. Makeup Air is one of those systems, but we also have incentives and supports for anything related to, say, common area lighting upgrades, window upgrades, if buildings are electrically heated, and just other central systems like domestic hot water systems, boiler systems, etc. So this is typically an offer that is targeting, strata councils or property managers. So meaning this is not for individual condo owners. This is targeting customers that are making decisions on behalf of the entire building. So because, as Jameson alluded to, these upgrades are expensive. So what BC Hydro is trying to do is, to some degree, alleviate those costs. The idea is to support customers to switch from an inefficient system to a more efficient system, and to a system that can potentially provide additional benefits like cooling, like Tony was alluding to. So because we know the upgrades themselves are costly, so we have on the right-hand side of your screen, you see the different, I guess, sub offerings or funding we have available for customers to take advantage of. At the very bottom, we have equipment rebates. So we have rebates, or we also call them incentives, to offset the capital cost of these systems. So in the case of a Makeup Air unit retrofit, there's, and I'll show in the next screen, but before we move on to the next screen, we have capital funding to offset the cost of these equipment. Now, as you also heard, it is important. These upgrades are complex, and it's important to involve engineers like Jameson and Stantec to really work out the feasibility, but also just the costing and just getting a sense of what options we have available, etc. So for that, we have feasibility study funding. We know that not every strata corporation has $30,000 just sitting there waiting, to hire a consultant and get them to do a feasibility study. So that's why we're providing that funding, because it is important to do that that study up front and really look at the different options so that strata corporations can make informed decisions. So I think $30,000 is a very healthy budget so that stratas ultimately get the right information in front of them. So professionals like Jameson are able to evaluate the technical feasibility, the costing, the implications. Do buildings need some sort of additional upgrades, etc., so that when Consult brings those to the ownership to make a decision, they have the right information in front of them. And then at the very top, we have this opportunity assessment funding. This is more like what Jameson was alluded to initially. This is just a smaller funding just to start looking at, what are our building systems, what are their stage, are they at end of life, which of my systems will soon require upgrades, etc. So this is just to get a sense of where our building systems, mechanical systems, electrical systems are at, and then start building a plan. So usually stratas would start at this stage, then start getting a bit more specific about, if they found that their makeup air unit system needs to be upgraded, then they go into this feasibility study. And so along all of that journey that Jameson explained to you guys, we have funding available for that. So next slide, Tony. This is, a condensed list of the types of rebates we have available for. And so what you have highlighted right in the middle is the incentives or rebates we have available for makeup air unit upgrades. It's important to say, and there's a distinction between whether the system is electrically heated. We probably don't see a lot of those systems, but some may be electrically heated, meaning they have some sort of electrical resistance to condition the air that is supplied to the building. But the majority will be fossil fuel heated, and meaning, natural gas is an example. These incentives are meant to support upgrades to become fully electric. So meaning full electric heat pumps, perhaps with some backup. But the idea is to help offset the capital cost, the higher capital cost that these systems would have compared to business as usual. Next slide. This is, at a high level, like I briefly explain this, but at a high level, what the customer journey would be. So the Strata Corporation will likely start at the opportunity assessment, and the consultants like Stantec would help them identify all of the opportunities that have in the building, and then they will essentially give them some advice as to how to move forward, which projects make sense to move, and essentially outline a priority list of projects. Then, if the corporation seems like thinks that they need to move ahead with one of these retrofits, they would go into the feasibility study and then the retrofit itself. Next slide, Tony. So just a quick sort of slide talking about the application process. We have an online, like the way to apply for a program is through an online application system. So the first step customers would do is to get in touch with an alliance professional, meaning a consultant like Stantec, but there's a very long list of consultants and contractors that are part of the alliance network at BC Hydro. If you don't already work with an alliance professional, whether it's a consultant or contractor, you can come to BC Hydro and ask for referrals. Then you would do an application online prior to do any work. So prior to doing an assessment or prior to doing a study or the retrofit, you need to submit an application. BC Hydro would then approve that application, and then you can go and do the work. After the work is done, customer comes back online, submits the required documentation of the completed documentation, and then they would receive the funding. So that's this application process is true for each one of our offers, whether it's an opportunity assessment, a feasibility study, or a rebate application. Next slide. this is a little bit less relevant for the conversation today, but I also wanted just to quickly highlight the fact that we also have, like I mentioned at the beginning, another program meant to be for individual condo owners. So these are rebates for in-suite heat pumps and hot water heaters installations in individual condo units. So one thing to note is that this funding is available only for electric to electric, meaning if your building is heated by electric baseboards. Heat pumps are way more efficient than electric baseboards, and we have this funding available to make that switch. So just in terms of rebates availability, we have up to $2,250 per heat pump, depending on the number of heads. If it's a multi-split system, if it's a single head system, we have a flat $1,000 rebate available, and then I think the minority of condo buildings have in-suite water heating. So we also have heat pump water heater rebates available. The majority, I mean, Jameson, you would know better, but the majority of condo and apartment buildings, they tend to have a central domestic hot water system, but we do find there's some that have in-suite water heaters. One thing to note about the eligibility for this program is that this is meant for larger buildings. For any stratas that may find themselves more in the, maybe duplex, quadplex, like smaller buildings, the eligibility for those buildings is the residential program called Home Renovation Rebate. Very high level, the application process is kind of similar to that of the whole building. Customer confirms eligibility. They request a quote from a contractor. These retrofits are less involved, so they wouldn't likely just go to a consultant. Probably a consultant may help strata come up with a plan. But the work itself will be done by a contractor. They should have approval from their strata to do these upgrades. They come to BC Hydro online application, request a pre-approval. Then when BC Hydro approves that pre-approval, customer would go do the upgrades. Then they come back and submit the documentation, and then they will receive the rebate. Just as kind of like a high level, if you need more information about what offers we have available, we also have offers for solar and battery incentives. We have a number of supports available. You can go on to bchydro.com/multi-unit offers to learn more about what I just very quickly glanced through. One thing to note is we developed last year towards the summer a heat pump retrofit guide for stratas. So this is a guide that essentially helps condo owners and condo councils navigate this, pressing, more and more common ask of owners trying to install heat pumps in their units. So this guide will essentially guide both of these condo owners and stratas as to how they can approach this process, because we know that it's not very simple. And then the other thing is very soon we're going to be introducing a new service of an energy advisor program to add this kind of additional support and capacity for stratas to guide them through these, very difficult and challenging decisions that sometimes the support of experts is very helpful. And consultants like Stantec and other mechanical consultants or electrical consultants, they're expensive. They're expensive to retain. They're expensive to get work. So this introduction of an energy advisor program would bridge that gap between, stratas and not knowing where to start, and then guide them through the entire process. So stay tuned for that. And that's it. I'll hand it back to you, Tony.
Thanks so much, Brenda. That's excellent. I also want to point out that we have a Makeup Air study that is underway. It's into year 2. It is in partnership with BC Hydro. We are studying 4 buildings that include Vancouver Island and the Lower Mainland to look at the temperature differences of the interior corridors in cycles throughout a 1-year period, with a heat pump installed that provides both cooling and regulated heating in the wintertime. So those studies will hopefully enlighten us, especially in the summer periods, because some of the reports during the extreme heat periods in upper floors in the common areas, the temperatures have reached over 45 degrees Celsius. And the difficulty with that, of course, is it voids warranties on building components, but it's just simply not healthy or safe. So, I'm hoping that we can start to have results from these reports within a year or so. And these are long-term research projects. They take time to evaluate full-year cycles, conversions, and other full-year cycles. So they go on for quite a while, but excellent research project that was funded by BC Hydro. So questions. We now have, let me just kind of pop into our Q&A here. Is the heat pump just for the hallway, or is it able to include individual suites? The Makeup Air unit is just for common area pressurization. It doesn't regulate temperature within individual suites directly, but it will have an impact because the air that's coming in under your door, especially through heat periods, is not going to be hot supercharged air. So it will have a very passive minor impact. Hopefully we'll be able to answer that though once we've done some studies. Can strata owners decide to do individual heat pump installations and rather than retrofitting the Makeup Airs? They're different. Jameson, Brenda, you can respond to this, but they provide 2 different purposes. The Makeup Air is for the common areas, hallways, corridors, and the in-suite heat pumps are just for the regulating of temperature inside units. That's why they're set up as 2 separate programs as we go forward. Typical range of cost for a smallish building? I don't know. Jameson, hazard a guess. Not to make light of it, but not less than 50,000, not more than 250,000. It's really hard to tell without actually doing the feasibility study, because there are so many variables that exist within the communities. Here's a good question that I had. Thanks, Rosemary, because Brenda, you're going to love this. What does a rebate per ton capacity mean?
Mm-hmm. And maybe Jameson, you can also help me answer this question, but it is essentially, the capacity, the size, in terms of capacity of the heat pump that is installed. And Jameson, maybe you can help us, illustrate us as to how these systems are sized.
Yeah, so I guess traditionally the equipment is measured often by tonnage, and then I think exactly as you said, Brenda, then depending on the larger capacity system would obviously have a higher tonnage, and then and I think the rebate is based on the tonnage size and how much capacity you have, and then there's a different type of rebates.
Mm-hmm. A quick question, follow up, I guess, based on the recent experience you've had, perhaps, are you able to give us a sense of, what tonnage we're talking about, and, maybe an example of the buildings you've worked on?
Oh, I might have to defer to my mechanical engineer, because I'm the
Okay.
coordinating engineer for a lot of these projects, but I'm not the specific mechanical person who works on this.
Okay. Yeah. No, I thought maybe, if you had it handy, not to worry, but I guess for say a a full electric heat pump, I think the rebate is $6,000. So if it's a 20-ton heat pump, it would be $120,000 going towards that. The
So
upgrade.
yeah, I think that's a really helpful value though, Brenda, because if we're talking about a mid-rise building that's 12 floors, with basically 10 units on every floor, it gives you some kind of sense of capacity of what the tonnage of consumption is going to be. So it's a pretty important calculation to verify when you're doing the feasibility, because it will give you a real sense of it. But it also is helpful to know that there is a sufficient amount of funding available to offset these costs. Obviously, the smaller buildings don't have the same benefit, but they also don't have the same cost or size of heat pump necessary. But most of our mid-rise, high-rise buildings are all really quite large. So I would say stay tuned, because we're going to have some of that data and information out of the studies that we're working on anyhow. So as we go forward. Tom, excellent question though. What's a sensible lead time to get a feasibility study in advance of doing an upgrade? How much, when should they start this ahead of, looking at the project scope and pricing, Jameson?
It usually takes a few months because the reason is just from the baseline measuring. Usually, you have to take a look at what the building is and how much energy we're consuming, and depending on the type of data that's available, sometimes you have to actually do on-site measurements as well. So and then from the time you do the initial assessment to the feasibility, it will take a few months.
And I think it'd be safe to say that with the consultant, you're going to ask them to be preparing the information and data that BC Hydro needs, so you can populate the reporting so they can get the refunds, or in fact do it on their behalf.
Yes, for sure. Yeah, and the more information we get, then the easier it is to gather the information, and then the quicker it is, and probably the cheaper it is for the owners as well.
Yeah, exactly. Sylvie, two great questions. Is this a requirement by the BC government or a recommendation at this time? The provincial government doesn't mandate these. It will at some point, because we've seen the dialogue, probably be a requirement of local governments when you're doing upgrades to make up air systems, that they be converted over to heat pumps. So my recommendation will always be, make sure your consultant speaks to your local government and determines what the minimum requirements are for conversions. And can the EV Ready report, which shows the capacity of electrical supply for our building, that's actually your electric planning report. Can it be leveraged for this project? I don't know that it's necessarily leveraged, but you two can comment on it. But it's an essential part of this transition, because you need to know what your electrical capacity is to start doing conversions in your buildings.
Yeah, I may jump in there, Tony. So maybe if the question Sylvie is referring to is, we do have we also have, same way we have funding available for energy efficiency upgrades, we also have funding for EV charging infrastructure, and we
Correct.
also have, and part of that also includes this EV Ready plan. Maybe that's what Sylvie is referring to. We often and we recently gave a presentation last week about there's an opportunity to stagger these two. So often ask your consultant if they can do both at the same time. Obviously, the EV Ready plan is very focused on the needs for EV charging. The opportunity assessment gives you a more broad picture. And undertaking these two can also support Strata's gain some efficiency in pricing for the required electrical planning report from the province. So even though these three things are different, they can often be done in conjunction.
One more question. It's excellent. I think all of the reports that you have need to be shared with your consultants, so that they are aware of every reporting system and how to leverage it, and if it has relevant information when you're doing this. Graham's question is, do you have a rough estimate of percentage of savings one could achieve by retrofitting a domestic hot water system in a 16-floor downtown building with a heat pump system. These are fairly newer systems, so cost of savings certainly can be estimated, but if you're converting from a gas-fired system to a heat pump system, there are a number of other things to take into consideration. One of them is storage, location of storage, and the retrofit storage requirements. So, but the cost estimate of savings, I would refer you to some of the consultants who are actually doing the feasibilities on these right now. The cost estimates are really not that easy to establish, so I wouldn't hazard a number on this at all. Jameson, Brenda?
Yeah, so I think the cost savings is always a tricky one because you are not only looking at just the mechanical equipment on its own because the quite often you are upgrading the mechanical equipment, but sometimes you're also looking at maybe you are having a higher performing windows or roofing and all those they play part of it as well, right? So when you do the feasibility study, often we will look at how do we get the biggest bang for the buck for the owners, and then and sometimes I guess the biggest bang is to change the mechanical equipment, but sometimes it is to upgrade the envelope and having a higher performing windows and roof and things like that.
Domestic hot water and makeup air functions completely separate, or is it possible to install a combined heat pump system? Well, in a perfect world, we would want to have one heat pump system that would be basically providing the resource that we need for all of these, but they are generally not connected. The domestic makeup air is an exterior system. Your heat pump for hot water is generally an interior system. So there are differences in location, use, demand for energy. Storage for domestic hot water for heat pump systems is still an issue that you have to resolve also because the storage demands are higher. So again, evaluate with a consultant, do a feasibility study to evaluate what the potentials are for your building. And the last question is, will this record of this meeting be available? Will it be recorded? Yes, and by tomorrow it will be posted on the CHOA website to our YouTube channel. So you'll be able to review it. And that, I think, oh, no, people keep dropping in more questions. We're a low-rise four-story wood frame. Are we too late to include a makeup air upgrade in the project to be doing re-roofing this summer? It would be tight. It's not impossible, but it would be tight. And I think that's something that if you're going to consider that, I would speak to a consultant, talk to the permit, to the local government, what your permit requirements are going to be, and start your process with BC Hydro right away. I think it's potentially doable, Brenda.
Yes, I mean, we can if I think that the best thing would be to engage a consultant that can support them through this process. Oftentimes stratas would go straight to a contractor because they know what to upgrade, and maybe that's the case here. But if they have a consultant they work with that can liaise with the contractors and the actual upgrades, I think there would be the ones that can help you navigate that timing issue. Now on the program side, yes, we can work on submitting an application and getting those approvals done so that they can get this kind of study feasibility work done prior to the actual project. Now, it is important that if stratas will be applying for funding from BC Hydro, that no work takes place before application for funding.
Right. So get your application and process started immediately in anticipation of going forward through the summer. We've seen some of them go through fairly quickly when they were well planned. So consultants can really make a big difference on this process. More info about maintenance and what's required cost. If you're dealing with a heat pump on a makeup air unit externally, just think of it like an engine. No different than an automobile engine. What type of services are required in the maintenance manuals that will come with it? Filtration is essential that the filters are changed quite routinely. Otherwise, you really stress out the system. It will perform lower, it'll demand more electricity, and its life cycles will be shortened. And there are generally lubrication issues that you have to deal with as well. But the systems themselves, when you're looking at them, will come with very good, very detailed maintenance manuals and requirements. So cost, it depends on the frequency and the cycle and who's doing the work, but it's certainly a work that you can have a mechanical contractor get into a service agreement for you on an annual basis. And we have no more questions, and we're right at our time. Brenda, Jameson, brilliant, both of you. Thank you so much. The BC Hydro programs are excellent. I know we do have members taking advantage of them, so I encourage people to look at them, go online, go to the programs, and definitely start a process. And the Energy Advisor Support Program is a program that, again, will help people navigate the systems, which is really important. So there we are. Thanks so much.